Hello friends! Welcome to Electrical Design Engineering YouTube channel. You can watch my videos in your language. Follow the steps to set your language. Step 1. Click the gear icon. Step 2. Select audio track. Step 3. Select your language. You may contact me for industrial design substation layout power system studies on +9 1700 647 4688, call or WhatsApp.
Hello friends, welcome to Electrical Design Engineering YouTube channel. This is our lecture number 5 of our free course DIgSILENT PowerFactory. In this lecture we will study about types of electrical loads which is necessary for the load modeling in DIgSILENT PowerFactory. First of all, we will see what is the load. What is load? A load is anything that consumes electrical energy to do some useful work. So, any device which consumes the electrical energy for doing a useful work, we define this device as a load. Example is bulb is consuming the electrical energy, fan, motor, TV, computer, etc. In power system studies, loads behave differently when the supply voltage changes. Based on this behavior, loads have three types. First one is constant impedance load, that is Z load. These loads act like a pure resistor or an impedance. The current they draw changes with the voltage. That means these are the loads whose impedance remains constant. V is equal to I, Z is the impedance, and this is V is equal to I, Z is the Ohm's law. If Z is constant, these are the constant impedance loads, so our Z is constant, so V is directly proportional to I. P is equal to Vi, since which is equal to V square by Z, because V by Z is equal to I, that becomes V square by Z. Since Z is constant, so P is directly proportional to V square. That means if the voltage decreases, current decreases, voltage decreases, current decreases, V is directly proportional to current, and power decreases. If voltage increases, current increases and power increases. Example of such loads are incandescent lamp, iron, that is the electric iron, geyser, water heater, hair dryer. These are some examples of the constant impedance loads. Second is constant current load, I load. These loads draw constant current. When the voltage changes, these loads change their apparent impedance to draw a constant current. Since P is equal to Vi, since I is constant, so P is directly proportional to V. Example of such loads are LED bulb, fluorescent lamps. Constant power load or P load. These loads try to draw the same amount of power even if their supply voltage changes. They adjust the current so that the product of the voltage and current remains constant. If voltage decreases, these loads draw more current to keep power the same. If the voltage increases, they draw less current. Example is computer, laptop, TV, microwave oven, induction heater, refrigerator, and air conditioners. Number third, it is actually number fourth. 1 minute. We discussed first constant impedance, then we discussed constant current, and third constant power, and fourth is the composite loads. Some loads are not purely Z, I, or P. They are not purely a constant impedance or constant current or constant power. Their behavior changes depending on the operating conditions, like motors. These loads are called composite loads or dynamic loads because their characteristics, their behavior depends on the operating condition. They change their behavior on the basis of operating condition. That is, they are called dynamic or composite loads. For example, fan, mixer, grinder, refrigerator, air conditioner, compressor, motors. In the real power system modeling, for load flow analysis, we use ZIP load model. Z is the constant impedance, so we take the constant impedance load as 30% and I 20% and P 50%. This percentage is given as per the IEEE. I have attached some IEEE research papers in the description about the load model, about the types of electrical loads. You can study these. These will be very helpful to understand the different types of loads and their composition ZIP. What is the percentage of Z? What is the percentage of I? What is the percentage of P? Or in for load flow analysis, we simply take the constant power loads. We consider all the load as a constant power load also. For transient stability and dynamic studies, we use ZIP model and induction motor. That means we composite load model here is equal to ZIP plus induction motor model. That means ZIP is the one model, and in addition to that, we study the motors as an induction motor model. Now, in the next lecture, we will show these different types of loads on the DIgSILENT PowerFactory. How you can set these loads, how you can define these loads in the DIgSILENT PowerFactory. Thank you.